gentlemen here in the lecture hall. I hope you enjoyed your lunch break and digested all the informations given during our morning sessions. Now we focus on one of the keywords, one of the magic words you hear in every discussion for years when it comes to the future of aviation, digitalization. And it's a great privilege to introduce our panelists to you. My welcome goes to, from Lufthansa Technik, the Senior Director Process Improvement and Lean Management, Johannes Weidisch. From SAP, the Global Vice President and Head of Aerospace and Defense, Torsten Welte. Welcome to, from Dassault Aviation, the CTO, Bruno Stoufflet, maybe via phone, I'm not quite sure in the moment. Welcome from the European Aeronautics Science Network Board Member, Professor Andreas Strohmayer. Welcome to the Managing Director of KLM and Martinair Flight Academies, Bart de Vries. From Airbus, the Senior Vice President Engineering, Stefan Römelt. And your session chair now is the Director, Safety and Flight Operations Europe within the IATA, Giancarlo. Bruno, Signore Bruno, you have control.
Thank you, and good afternoon to everybody. Thank you for joining us this afternoon on this panel about digitalization. I'll just keep my introduction very short. We hear a lot about digitalization, but in aviation, every time we talk about digitalization, we're mainly talking about ATM or certain specific areas. I think there's a lot of room for better digitalization or more digitalization in all areas that involves an airline or aviation in general. And I think that along the entire supply chain, a better use of digitalization can help us not only in getting out of this present crisis, but also to improve our safety levels, which are already very good, and most importantly, also improve our efficiencies. So without further ado, I'll pass to the panelists. We have a distinguished group of panelists today coming from various sectors of aviation. And I'd like to start with Johannes from Lufthansa Technik. You work from a maintenance repair overall organization. And I'd like to ask you to start with what potential do you see in digitalization to elevate the competitiveness of MROs of organizations like yours to the next level? Thank you, Johannes, over to you.
Thank you, Giancarlo, for the question. Well, maintenance, repair, and overhaul of aviation is a fantastic area I like to work in because there is still a lot of waste today in our overhaul processes, in the shops and in the hangars, and this waits to be removed. There's lots of waiting time and unplanned work to do, so a lot of good problems, as I always call them, wait to be solved to improve competitiveness. And many MRO companies, like Lufthansa Technik did, we have been using lean production methods in the past to create process transparency in order to identify waste and to remove it to increase the amount of value-adding tasks to better fulfill our customers' expectations. And this, to my understanding, is where digitalization comes in to improve competitiveness of MRO operations. And besides the focus on operational aircraft data collected downstream from aircrafts and engines for predictive maintenance, and I'm sure we'll talk about this today also, I'm sure it will be crucial for competitiveness of operations to collect and to make use of the upstream data being produced from our workshops and hangar operations, like a digital twin of a production shop. So MRO shops are able to generate lots of data, which to a great extent is still unused today. Movement data and timestamps of material, of assets, test stands, or even employees is either not yet generated in many shops or not exploited to create higher transparency of process performance and to detect improvement potential. Today, digital is, to my understanding, not yet leveraged to significantly improve performance. We have a lot of untapped efficiency potential, a lot of waste in our processes. We're still talking about days and hours of improvements. Secondly, we still have a lot of analog-like interfaces. So we are still used to manual customer updates via phone, or there's still copy and paste of shipment tracking numbers from forwarders to our customers by email. I always say that every keyboard in a workshop is suspicious, as it means that we are manually entering data in our production. The third potential comes from that our human intellectual property is not yet codified. So we have a lot of knowledge of decades of people who know best how to repair a part or an aircraft. But we have an aging staff and a soon retiring staff, a lot of them. And we have digital platforms in the market. And today we're also on the panel we're also even competing on these platforms. They're talking about predictive maintenance. But I'm still sure that for the shops and operations, there is a lot of potential that can be covered. The first, to my understanding, is that I always call it data-driven lean management, because I'm originally coming from this. And these lean people are very good in identifying the best problems. And with digital solutions, I think we have the best solutions. And if we team them up, I'm sure that there's a lot of potential to improve the performance of shops. The second important issue is to use digitalization to create a good digital customer interface. So our customers are airlines. And if we allow our customers to look deep into our processes, it will give a big push on ourselves on improving the performance of also our back office processes to fulfill our customer expectations. And we are in the course to finding a way how we can codify our human IP so that our people are training machines that tell them what to do instead of doing a lot of planning in our shops ourselves. So there is a saying that in a company, you only have two allies. That's your customers and your employees. And I'm sure with digital, for both of them, we can make life easier. For our customers, we can make it easier to make business with us. And for our people, like with the lean logic that we have been doing for a lot of years, we are striving for making their work easier. So to remove obstacles, enable that they're better able to perform what they're really educated for and really paid for, and that's repairing aircrafts and components. So that's just a short point of view from my side, and I'm happy from how different sides we will discuss this topic today.
Thank you. Very interesting. I got a bit concerned when you say that you are worried when you see keyboard in the hangars, because maybe I am old, but I still remember a lot of pencils and books and papers. So that's an entirely new dimension. We'll get back to this later on. Let's now move to another sector. And I'd like to go to SAP, who is a provider that provides lots of solutions in aviation. And we have with us Torsten Welte, who is the Global VP and Head of Aerospace and Defense at SAP. And Torsten, very soon looks like the world of aerospace will be data-centric. We hear a lot of that. We hear a lot talking about big data and so on. But what impact does this have on the passengers, on their digital journey, as well as the digital twin of an airplane? And moreover, what opportunities do you think exist, and what barriers we need to remove to improve this journey and increase efficiency of the operators in the end? That's all we are looking for. Over to you, Torsten.
So hopefully you can hear me.
Very well.
And others, can you hear me? Okay. Thank you, first of all, for having me, and greetings from Seattle, from the other side of the world. I'm honored to be with you in the esteemed panel. So at least thank you for being virtually with me or having me. As Mr. Buono said, my projection is that by 2025, the world of aerospace will be data-centric. What does that mean? What are the drivers behind it, right? The aerospace industry drives really on constant improvements. That's the core, the center of our industry. Improvements for the travelers, for the crews, for the mechanics, for the operators, and also for the environment. It is super, super critical that any of the improvements come to life in shorter periods of time, in less cost, to bring really the innovations and the improvements to the market. To do so, that's driving on digitalization as a major enabler for this. We saw during COVID that a lot of work shifted home. A lot of people worked from home and had to really pivot their work environment to a new environment that's only possible through digitalization and digital tools. The same thing is happening as we see it right now in the vaccination development. A lot of the speed of new development and testing is based on digitalization. So digitalization as a core to our industry and also to our life is going to be essential. And it's not anymore just a nice to have of having a cell phone that you can access information, but it's access to necessary critical information. This will also be reflected by the new trend of traveling in the future, the new normal. Travelers and operators will have to have all kinds of information available in order to really move forward in their lives, in their environment. That's all pivoting now over into the design, manufacturing operations. For companies, if there's manufacturers, operators, or support people, the access to information, access to having the information at your fingertip is going to be critical, because all of that information is going to be critical to make decisions, to have a safe environment, to have an efficient environment, and also to bring everybody back to the places where they need to get to. That is going to be a critical environment. But in order to bring all these innovations into the product, into the market, it's going to be critical to capture all that information from the different areas and connect them. We're talking about transactions, we're talking about data, about the objects itself. And if you look at the right-hand side of the slide, when we talk about digital twin, the digital twin is basically a physical element that is replicated in the data world. But that's not just a physical object, but it's also the elements around it. In order to really improve and reduce the time for innovations and to collaborate more efficiently, we need to capture all the different elements of the data around the object, the situations, so we can simulate and improve processes to make faster decisions and to make better decisions. That's going to be some of the key elements in this. And this is for the traveler, this is for the manufacturing, and this is also for the operators. It's for everyone out in the world, and they need to also focus on a much more improved collaboration in this, because it's not going to be one entity or one group that's going to drive some of the decision, but it's the sum of all the members in the chain that will have to have access to the data and to collaborate efficiently with each other. So with that, I'm going to give it back to Buono.
Thank you. Thank you, Torsten, for providing us with your perspective. I'm just learning what a digital twin is. I am afraid to say that before we were preparing for this conference, I've never heard of this, but it appears that, you know, this is one of the areas where we can gain a lot from digitalization. And after having heard the point of view of a provider such as SAP, I'd like to move on to hear from manufacturers. And we have Bruno with us, Bruno Stoufflet from Dassault Aviation, is the Chief Technology Officer. And it would be interesting, Bruno, to understand and to discuss what are the various aspects of digitalization for a manufacturer such as your company, Dassault Aviation, and what are, once again, the major challenges in this journey. Over to you, Bruno.
Thank you. Do you hear me?
Yes, very well. Thank you.
Very well. Okay, thank you. Sorry for the inconvenience to be on the phone. Sorry for that. So my name is Bruno Stoufflet. I'm CTO of Dassault Aviation, and as you know, Dassault Aviation is a manufacturer of combat air systems and business jets, and is acting as an architect integrator with a dual activity, and is pioneer in digitalization. So, of course, digitization comprehensively affects all activities of a manufacturing company as Dassault. I will come back on this, but first, I wanted to give an overview of what it brings in terms of capacity to reconsider the product with disruption that can be offered to the customer. So, starting with a digital product, I would say, I see three major evolutions where digitization is a key enabler. First of all, digital techniques bring the capacity to increase automation and to develop assistance to the pilot. And of course, the development of artificial intelligence, and which has to be robust, paves the way for more and more autonomous and assistance to the pilots. And artificial intelligence is considered as a game changer for increased autonomy, and it's part of digitization by itself, based on machine learning, and for example. The most challenging issues regarding artificial intelligence are, of course, the acceptance by pilots, by users, the necessity to qualify and to certify the function that will have artificial intelligence algorithms, and something which is sometimes forget is that we have to understand the benefit in terms of operational cost. It has to bring a value to the customer, and it's not so obvious to evaluate this. The second, I would say, the second capacity that digital techniques bring is the capacity to bring value to the customer with short cycles. We are used to long cycles in aeronautics, in our business, and with digital techniques, we can provide complementary to conventional embedded system. We can provide new function in a short cycle, taking advantage of having tablets now in our cockpits, electronic flat bags, which are now really full-fledged components of the system itself. And the key issue, the key challenge is to master the architecture of the whole embedded system, from the most critical part of the system up to the open world that is now accessible in cockpits, weather forecast in real time, situation around the aircraft. We can come back on this if you like. The third issue regarding the product is now, and it's on my first slide, the wide spectrum of services that we provide, I would say complementary to the traditional product, which is the aircraft itself, services for the pilot, for the passenger, for the maintenance operator, and which are only possible and only accessible by digital techniques. An example of a service which is now deployed is consisting in prepositioning to aircraft, which can be quickly assigned to deliver spare parts, provide transportation solution to customers in case of no dispatch situation. It's really a complete service based on a digital infrastructure featuring connectivity, decision-making. It's called Falcon Response, and it needs a truly dedicated information system. So that's the three major evolution I see for the product, but of course there are some others. It's just I wanted to focus on some of them. The second part of my introduction is dedicated to digitization for the enterprise itself, for the company itself, and processes. And I have also three major areas I see today. The first one is what I would call the global system approach. We have been using digital mockup, for more than 30 years, or 20 to 30 years, which has been enriched, I would say, through the different aircraft program we have, and now it's a real product life management system we have, which deliver the management of the product during the whole life. The challenge we have now is really to aggregate more and more and progressively models describing the aircraft, behavioral models, simulation models, and taking advantage of having this unique database. And today, we are far from having a real collaborative, seamless process where you would attach, I would say, the various description of the product, and especially in the early stage of the design. The second area.
I think we have lost Bruno. Yes. Okay. So while we try to reconnect with our colleague from Dassault, in any case, his presentation was quite complete, and I think we all understood the benefits that can be achievable by manufacturers, not only in the production phase, but most importantly, I believe also in the support phase of manufacturing, which is what comes after a product is delivered to the customers. Bruno, can you hear us? Okay. Sorry about the inconvenience. So we heard about manufacturers, but every time we talk about digitalization, I still hear about people. People are still at the center of the system. Aviation is still planning to use our professional, of course, and we need to make sure that also the new generation of aviation professionals will be ready to take on the digitalization challenge. And that's why we invited today another colleague, which is Professor Andreas Strohmayer, to give us a little bit of a perspective of how the digital transformation will influence research and teaching, but most importantly, what are the consequences that this will have for the output of university, for the professionals of tomorrow, both in terms of the young academics, but also the results of research program on which, as we all know, aviation is heavily based. So, Professor Andreas, over to you. Thank you.
Yeah, thank you, Giancarlo, for this interesting question. And I'm not sure we have all answers already at hand. At the moment, thinking of digitalization, the first that comes to my mind is that we are busy all over Europe to improve our online teaching capabilities. And as you all know, sometimes a crisis can be helpful to speed things up. But for a real digital transformation in aeronautical research and education, a lot has to be put in place still. As Bruno just pointed out in his speech, the objective of digital product in design, digital transformation in the design cycle, is to shorten the cycle for the increasingly also complex products of our industry using such a digital model of the aircraft. And this would first of all apply to the core development process, so from design to testing up to a digital certification. But it shouldn't stop there. So the aim is to control and regulate all life cycle phases, not stopping at certification, so which would be the as designed model, but go on to the as built, the as maintained model of the aircraft. And in such a digital representation of the physical aircraft system, and Torsten Welte just pointed it out, the digital twin, so-called, we have to store all kind of data, like the 3D model of the aircraft, models and data on aerodynamics, on flight physics, on structural loads, on production and production deviations, on records on operations, on inspections, on maintenance. So a whole lot of data that comes into this digital twin. And then the good thing would be that we could analyze this under every different aspects of interest. So whenever I have a specific focus, I can look into this big data and see maybe some schemes that are common to my problem. So what do we have to do in research to get this to life? We have to bring all these data and simulation models to life one by one. And then once we have all these simulation models side by side, we have to implement the interfaces. That's what's called the digital thread. And not threats like it's threatening us, that's the digital thread. So that's combining all these different models. And Then, once we have all this in place, we have to validate all these simulation tools. And ideally, here the operational data would come in. So we could refine our tools and models with actual operational data from the operators that would not allow us to improve future products by, for example, reducing safety margins. Typically in aeronautical design, we have safety margins to comfort ourselves for what we don't know too much about what's real life. We could also get closer to a simulation-based certification process. So that would, and it was pointed out before, save time and resources. Operational data at the core that would also allow us to analyze design alternatives in a more relevant environment than what we have on our boards. Improve to assess the effects of design choices on cost, on other figures of merit. So that was the research part, a lot to do. But what does this mean to, as you said, the young generation, the future generation of researchers and engineers? I think the digital twin, and if you learn about it first time today, our students also should learn about it. It has to be more in the focus of our courses, of our classes. It could be used in teaching, in hands-on courses. We could have virtual experiments, just as virtual reality. We have to get more virtual space in our classrooms. The handling of big data, another important point. So important topic, how to deal with this huge amount, gigabytes, terabytes of data. Maybe artificial intelligence would come into play here. And we as researchers, for our research work, we have to get used also to provide access to raw data of our research in scientific publications. Finally, model-based systems and simulation engineering, the multidisciplinary approach has to become part of the basic skill set of young engineers. What does that mean? That means they have to know about this multidisciplinary approach, but we have to put more emphasis on the interconnections, the connections between different disciplines. We have to take mechanics, electrical engineering, software engineering. We have to look into the interfaces, and the young student has to learn about how to interface all this. So we should no longer teach in silos. We should build bridges between our faculties. So you see, digital transformation will keep us busy in academia. But first of all, as I said in the introduction, we have to get our online courses on track. Thank you.
Thank you. Thank you very much. And thank you for delivering your point of view perfectly on time. That's really appreciated. Before we move on to our next speaker, I'd like to give the floor back to Mr. Stoufflet, if he's with us, to finish what he was saying, because you were cut right in the middle of your presentation. I'm sorry about that.
No, I'm sorry too. I don't know exactly where it came from. Do you hear me this time?
Yes, very well, thank you.
Okay. I don't know exactly where I was, so I shifted to the digital enterprise and company and processes. So I tried to give you an overview of the major areas in this field. Global system approach, trying to really enrich the digital mockups, product class management system we have today for designing, producing, and maintaining our products. So it's a real whole life process we have, but it's incomplete today because we have progressively aggregated behavioral models, simulation, but only partly. And we don't have a real collaborative, seamless process. And I think this is something where we can have some discussion about how to really attach the various description of the product, especially in the early design phases that was addressed just previously, where you iterate a lot and the product is not completely defined, but you need to have a coherent vision of the architecture and the different performances of the product, of course, with simulation at this stage. So I shifted to the second area, which is linked to the competitiveness of our industry. And the competitiveness is very linked to the manufacturing efficiency that digital techniques can provide for our future plant, extending the design capacities, not only of the product, but of the product and the manufacturing system at the same time, in order to really develop a product that will be efficiently produced in the future. But also other aspects of the digitization of manufacturing is linked to the efficiency of piloting operation from end to end, with generalized cockpit in the plant itself, real-time management of the production, the prediction maintenance of tools and means, etc. But we can come back on this. And I wanted to finish with what is a real enabler of our efficiency is, of course, big data. Big data, which really breaks up the organization, the siloed organization that we can have in our companies, as data which are were managed locally now has to be correlated with other data in order to provide added value in treatment, in analysis, in synthesis, and these data are no longer managed locally, but now have to be brought at the collaborative level. So that was the third area, which is really an enabler for enhancing the efficiency in the company in terms of not only design, with the capacity to have retakes and return of experience of real operations, but also in manufacturing and in maintenance and in operations, where now we can really analyze fleet events correlated to what has been the events in the production phase, etc. Okay, so I wanted to end the introduction that was cut on this topic of big data.
Thank you, Bruno, and thank you for elaborating more on this. And we'll get back to some aspects of your very interesting presentation later on. And I would like to give the floor to Captain Vries, who is the managing director of the flight academies of KLM and Martinair. Not only that, he's also a very old friend of mine and the advisor operations strategy at KLM, which means that in his role is also the vice chair of the European initiative ACAIR. So Bart, in your opinion, we see that digitalization is already well underway in many aspects of the commercial aviation world where we both of us work. However, what are the further opportunities out there that could benefit all the stakeholders in the value chain that we still haven't taken advantage of? Over to you, Bart.
Giancarlo, I'm very sorry, I could not hear you. I can hear everything else, but I have not heard a word of what you said. So I presume you said some introductory words on me, and I will just go ahead and do my brief introductory speech, if that is okay for you. Just a brief check. You can hear me? Yeah, okay, great. All right, well, it is challenging. Let me start off to say that I'm grateful that I have the opportunity to be part of this excellent panel. Now, as a representative from the airlines and as a vice chair of ACAIR, that is exactly what I try to do, represent the end of the chain. I can only say that you can all probably imagine how much we are suffering at the moment. The airlines are in the most difficult time ever. I'm sure recovery will come, and governments in society will need to work together to make sure that this recovery will go as soon and as smooth as we can. Challenges will remain when we do recover, and new challenges have actually been added because of this crisis. Now, let us make sure that innovation, and digitization is part of that, but many things on this conference have already been said about innovation in the broad sense, is the key to the future of aviation, not suppression. And I think that is important that we underline that going forward. So taxes and extra suppressive measures against aviation will not help us. Alternative fuels, new infrastructure, digitization, that will help. Now, already has a lot been done, and many of the esteemed gentlemen in this panel have explain things that are being made today. We have already achieved a lot. We have CPDLC, we have EFBs that are now electronic, we have biometrics for passengers, we have excellent maintenance processes improvement because of digitization, but there's still a lot of ground to cover. And as airlines, I cannot underline enough that we need to move fast. We do not believe that horizons that go as far as 2030 or 2050 are appealing enough for today's traveling public and today's politics. So yes, we need to continue to work on these far-fetched and high-esteemed goals, but we also need to work on very concrete results that we can touch tomorrow. And digitization can help us there. How can we achieve more speed? We've heard the CEO of Airbus, we have heard the CEO of Boeing, and we've seen Patrick Key yesterday, and all of them basically said the same thing. Yes, we need to increase speed. Yes, we need to move both fundamental steps and incremental steps, but we cannot let aviation become less safe. As a matter of fact, we need to be safer than yesterday. Perhaps certification rules, and they have been mentioned already in the past, can help us if we can perhaps digitize the certification process itself to make sure that we can have solutions quicker. What could be an example? Well, for example, at traffic control, I believe that if you would digitize that, well, let me put it another way. If you would take somebody from Google and you would show them how we do air traffic control today, they will probably be surprised that it is still manual work with a person talking through a radio to an aircraft to make sure that they are kept separate, while technology is already there to make sure that they are automatically separated and nobody even needs to talk because you can do it through data link. But we don't use that technology today because to certify it and to get all the actors in the chain on board is a very, very big challenge. How can we speed up this process? That is the real question I think we are facing, and digitization and regulations is what we need to make sure that we speed up. Now, one other thing that I would like to throw out there, if you like, is what can we learn from this current COVID crisis? If we just said that we need robust processes and certification to enable safety, maybe we can learn from the vaccines that will come out there today for COVID, because the medical world is facing a similar challenge. They need to move faster than they have done in the past to make sure that they come up with a solution for this big problem. And maybe we can learn from that. Maybe there is faster ways to certify something to the similar level of safety as we've done in the past. And our CEO from Pipistrel has rightly pointed out that it sometimes takes 60 plus years for something new to come along. So maybe we can find ways to look at the way the medical world has done this and speed up our own processes to be certified quicker, to make use of new technologies quicker than we do today. Now, with that, Giancarlo, thank you for this opportunity, and I look forward to our further exchanges. Thank you.
Thank you, Bart, for providing this interesting perspective and point of view. Now, to finish with the first round of questions to the panel, we have last but not least Airbus, which is certainly a key player, of course, in aviation across the globe. And a major, as you all know, manufacturers. We have with us Stefan Römelt, who is the SVP Engineering, Head of COC Cabin and Cargo. And Stefan, I'd like to ask you very straightforward, what is the digital vision at Airbus? Can you tell us something about this? Thank you.
Thanks, Giancarlo, and good afternoon from Hamburg. Airbus is always known for its technological breakthroughs in aviation since the beginning. So our digital vision today is to deliver a new platform consisting of processes, methods, tools, complete new business models and ways of working to develop not only a product, but the next generation of Airbus products. So what does this allow us to do? It will allow us to rethink the complete life cycle by transforming the way we design, manufacture, and operate our products from the start, offering digital continuity by design. To demonstrate our vision a bit further, I would like to share a little video with you.
Since its beginnings, Airbus has been making its mark on the evolution of aviation. Innovation, technological breakthroughs, new ideas and new accomplishments have come quick and fast. The world is changing, and the speed of change is increasing. Airbus faces high customer needs, growing traffic demands, and increasing societal expectations. With digital design, manufacturing and services, Airbus strives to deliver a breakthrough in customer value, enable Airbus people to unleash their full potential, and be a key actor in building a sustainable future. We aim to create innovative approaches to reimagine the way we co-develop our products, bringing manufacturing and services to the heart of the process. We are defining new organizational models and collaborative ways of working to increase agility, simplicity, and continuity. Decision-making is quicker. Using digital continuity, modeling and simulations, we will bring to life the collective intelligence of all our teams, our partners and our customers. Harnessing the knowledge, experience, intuitions of our diverse teams, whether they are doers, thinkers or planners. With DDMS, Airbus will shake up the aerospace business, reinforce the commitment to our customers, our people, and the needs of both society and the environment. Digital design, manufacturing and services is pioneering the future.
So, as you have seen in the videos a few seconds ago, our Airbus Digital Design, Manufacturing and Services program, DDMS, drives the digital transformation through the 5 pillars, which are data continuity, modeling and simulation, product line approach, co-development, and human transformation. I am sure, and I think Torsten explained it very well, that you all agree that without seamless data continuity, the digital transformation is simply not possible. So what we aim at Airbus and what we are already progressing in is to model and simulate everything from the top to the bottom of product development, leading up to the industrial system, the services, and our customers. This will pave the way for us not only to develop our future products, but a complete product line with maximized standardization, modularity, and reusability, taking wherever possible already benefit from pre-developed architectures and components. However, this will only be feasible if we have a collaborative co-development end-to-end from all the actors involved in the chain. This means we need to break the traditional silos of our business functions, both inside the company and external with our partners, authorities, and the customers. In this amazing digital transformation journey that we are together, it is more important now than ever to accompany our people, not only Airbus teams, but also the complete ecosystem, including up to the passengers. We need to make sure that we guide them, we take them by the hand and support them to foster new ways of working, constant upskilling and developing of the new key competences. However, never overlook the need to drive also a huge shift in mindset change. Okay, why is this digital transformation so key for Airbus? Since its beginning, more than 50 years ago, we have pioneered many firsts through our passion and innovation, transforming the industry and helping to move forward the whole society. So it is only natural that we will continue with pioneering innovations to digitize aerospace design for the industry and for the people. Thank you.
Thank you. Thank you very much, Stefan. It's very fascinating, of course, to see how Airbus is planning to embed all of these in the future product in the way that you are working. And it's now time for some questions. I've seen one very interesting question from the floor, which I was thinking of as well, because I mean, we understand after we heard all of you that digitalization is based mainly on the availability of data. And we all know that we are sitting on a mountain of data. But one thing is to sit on a mountain of data, and another thing is to give some meaningful, give some meaning to this data and use this data in the proper way. Not only because, of course, interpreting data requires itself, requires a lot of efforts, requires technology, but also because of the regulatory environment that we are in. And let me remind all of you that aviation heavily regulated environment. So the question to the panel, and maybe there will be some volunteers that will raise their hand to have a go at this, is are we ready to actually use this mountain of data that we're sitting on, and do we have the right regulatory setup for this in aviation? And if not, what it is that we need to change, and who could be the lead driver for this change that is needed, keeping into consideration what we heard also from Bart, which is we need speed. This is not something that we can stop thinking of. We need to implement, we need to start working with this data. Anybody wants to give a try to this question? I don't see any raised hand. Otherwise, I will... Torsten, please go ahead.
Elements of it. As we know, a lot of countries have regulations that operational data has to stay in the country, as an example, or GDPR or other elements if it goes into people data. The element of using all the data is going to be critical because, as for example, if you look at a repair of a part, it's always important to understand how that part was used. As Professor Strohmayer explained before, you have to simulate it in that data, in that environment it was used, so to correlate all the different aspects of it so you can actually identify a defect in it. The same thing is for a traveler, right? If they travel specific legs of it, going from one airline to another, or going into an airport and out, or a hotel, or whatever, it's going to be critical that we have the mass amount of data and we can share it. Meaning we have to have certain ways of collaborating in standards, outside of standards, and also respect the privacy of not an individual, but also companies in this process. So there's a lot of groundwork to be done. There's some activities that are already started in this area. I'm just referring back to Gaia X. That is one effort in Europe that is started now, where Airbus last week asked for many of the aerospace companies to join to really establish basically a collaboration. Because, as I said before, the collaboration in the supply chain, in manufacturing, in design is going to be critical. And it has to be secure, it has to have standards, and you really have to support each other in this process and prosper. Everybody in the chain has to prosper with this. So that's going to be super, super critical. In addition to the fact that we need to have the computer power to process and find the needle in the haystack. But I think that's less of a problem because that's a technical problem. A lot of technical problems we were able to solve over the years. I think the data standards, the rights, and making sure that everybody benefits off of that, it's going to be super, super critical.
Thank you.
Answer could be, as always, it's like if you have this big elephant in the room, you need to slice it and go step by step. and we might not even know all the answers from the beginning. And it's not that we are starting today. For example, we have launched our data platform for our customers, the Skywise platform, 2 years ago, and it's already a big success working with the customers and sharing data and offering services on this data platform. And since we started, we learned already a lot on it. And I think it's not a question, and this what I really appreciate is I think it was also heard by the panel, is that we share the same ambition. We acknowledge that we need to do it in a collaborative co-development, if I come back to my engineering profession way, and we can only do it together. And but it's not that we are starting from zero. There are already good initiatives.
Thank you very much. And linked to this, I think we heard about collaboration and the importance of collaboration. There is a very interesting question on collaboration, a bit more pragmatic and practical, coming from the floor to Bart, which is, Bart, and good luck with this. How would you bring César, Clean Aviation, EASA, NSPs, airlines, airport closer together to accelerate the goals that you have raised, to accelerate, to speed up this journey towards digitalization?
I guess that is $1 million question. And if I would know a simple answer to that, then I would probably be in another place right now. But I can make some comments on it. I think what we sometimes lack in the entire industry is that we don't have the same common vision as to where we want to be. So, and if you mention all these organizations, they all try to move in sort of the same direction, but have we really defined what does good look like? Have we sat down and said, okay, so what do we want to achieve and how can that work? Maybe even starting with a white sheet of paper. So conferences like this one we are having today, I think are helpful, maybe should be held more broadly. And their own organizations such as IATA and the regulators and other industry bodies would maybe come together in a more structured way to talk about what does good look like. Because I see many small projects that are effective in themselves, but they are not necessarily pieces of the same puzzle. So if you piece them together, you don't get an integral picture yet. So that may be one path that we could look into to make sure that we define a road that we can all travel on.
Thank you, Bart. Changing subject, there is a question that I would like to address to Professor Andreas. Maybe you are the best one to try to answer this question. And this is as follows: is there any specific role for big governmental research center for the qualification and certification activities inside the digital transformation arena? You want to try to give an answer to this question? Is there any role for the big governmental research center or anybody else?
Let's start on that one. As it just was said before, it's about collaboration, and all stakeholders in this process have to work together. It's not uniquely academia or uniquely the OEM. It is all together, the OEM, the suppliers, the operators, the maintenance organizations, and the big research organizations. They all have to work together. We need a lot of data also for this validation process. Of course, big infrastructures will play a role in there. Is that already an answer, or do you need more elaboration on that one?
Thank you. Anybody else has any opinion on this? No, we all agree with Professor Andreas.
I think it is important that that the industry is helping to define the requirements on the profiles we will need to master this digital journey. It makes no sense to train and to educate people at universities which are then not fitting with the requirements of the manufacturers and of the industry, which are then to take them to help them on the journey. I think that there needs to be already a collaboration in the definition of the requirement.
Thank you.
One more comment maybe to point back to what Bart said earlier in regards to collaborating with other industries, right? In regards to getting the vaccination faster to the market and approved. I also think as an outsider, not necessarily an aerospace defense company coming from a software company, the collaboration and innovation cycles will draw in also new players, meaning people from the tech, people from other industries. The cabin experience can completely change by looking at players in the media world or other areas that potentially have not done anything in aerospace. But I think the convergence of different industries to innovate, to create the experience, to create the safe environment will really draw on the collaboration. And I think, as you said, Stefan, before, the bringing together the different players is going to be super, super critical. And there are going to be new players and new kids on the block that probably also have a different tact speed, right? And that's going to be extremely interesting to see how do we
Thank you, Torsten. Let's slightly change subject. There is a question coming from the floor, which I found quite interesting, and it's something that has been crossing my mind as well. So I'm learning now from the questions that I'm receiving that not for all aircraft we have the availability of 3D digital master data. And also there is a field that whether manufacturers are actually working to achieve full digitalization in the design process, the same activity is not really be seen for service providers. So linking to this question, I'd like to pose a question, and starting with Johannes first. What I'd like to discuss with you is we still have a huge part of our fleets flying around the world that is not necessarily very new aircraft. I mean, we are still operating aircraft from some time ago. We still have old so-called technology, although this crisis is certainly accelerating the phase out of older aircraft. But is the aviation world ready for this revolution in digitalization, especially in terms of the fleet operating today? And if not, what would be the investment required, for example, by airlines to upgrade their fleets, considering also the specific situation in which airlines find themselves today with not much to invest? How can this happen? Johannes, you want to try?
Yes, I will start off. Well, the biggest asset that we have as a independent service provider in the airline industry is that we know, and sorry for that, Stefan, we know much more about the operating Airbus aircraft of the past, as probably Airbus would know, because we have a lot of people knowing all the tricks and ways and how to fix all these aircraft and components. So this is the knowledge of, like, from the legacy aircraft that we will need to use and also to codify and able to be better in then performing for our customers. As you said, our customers, the airlines, they won't have any money to invest. So you need to be, there will be a lot of overcapacity also in the market in the MRO business. So it's a must for us to push the competitiveness, and also from what we have learned from the past, repairing all these aircraft and components, to be best at that and invest in that. And for the new aircraft, I think it's a must. So if you are not collaborating with the big OEMs, then for an independent service provider, it's hard to still be in the business.
Thank you. I'll certainly leave Stefan to respond to this, but we...
Do you hear me?
Yes, go ahead.
Buono Stoufflet speaking. I'm on the phone.
Yeah, I was giving the floor to you right now. I just I also wanted to ask you on top of your comments that you have, do you feel as a manufacturer that your service providers are ready?
Service provider? Well, which kind of service provider you mean?
Well, let's say more than your service provider, your contractors, the ones that are working with you, that are providing you, for example, with parts of the aircraft, with engines and so on. Is everybody ready in the value chain?
I would say large companies, they are, yes, sure. Engine manufacturers, they are even ahead of us in terms of data acquisition and treatment of events in the fleet. But of course, in the value chain, we have small companies, and they are not at the level that would be sufficient. But in terms of manufacturing, I mean. But I wanted to come back to your point on the how to increase the level of digital solution for all the aircraft. I think the major issue is to really understand if there is a benefit at the. Do you hear me? Yes.
Yes.
Okay. The issue is really to understand if there is a benefit in terms of cost, because it would cost a lot to fit this aircraft with digital solutions, and at the end, I'm not sure that we would have a return on investment, because as it has been said, we know a lot on this aircraft. In terms of maintenance, we have not so many challenges because they are old and all the I would say the problems have been fixed, and so usually what I see is that the challenge is linked to aircraft which are coming into service, where you find a lot of problems and where you have to treat them very rapidly because you are in a curve of delivering this aircraft, which are widely used, etc. So I'm not sure that there is really a case to invest in digital introduction for all the aircraft.
Thank you, Bruno. And I mean, I'm not an expert in the type of operations that your aircraft are performing, because they're mainly executive aircraft. But certainly in commercial aviation, we've been saying for decades, we need to have positive cost-benefit analysis anytime we implement new technology. But unfortunately, this is not always the case. We also see that certain decisions are taken either at a regulatory level or at other levels where we are forced to implement certain technology, sometimes rightly so, because we need to move forward, but without necessarily proper cost-benefit analysis. So I couldn't be more happy to hear what you said. But before we move ahead, Stefan from Airbus, do you want to comment on what was said before? I mean, you were mentioned, and we heard from an MRO that they know much better your older products than you do. Do you have any comments in this respect, or in anything else that was discussed now?
I think what is clear is that for our classic models, I would call them, which are still around, the long life cycle of the product is not always helpful when it comes to digitalization. For the younger products, for the where we and you should not forget, we were the first ones to introduce a digital fly-by-wire for the A320 now 30 years ago already. And of course we generated data there, and there are not only areas in those old aircraft which are totally, I would say, uncontrolled. We have where we have digital in the avionics, in the flight control, wherever we have electronic control, there was always the chance also to monitor and to store data and to do a data evaluation. In some parts it's not there, and it's super costly to have a retrofit. There are other parts of our aircraft, for example, if you take my profession, the cabin, where you have sometimes 3 or 4 cabins in an airframe life, where you could do already something in terms of upgrades. And what we are working on now is new connectivity solutions for upgrade of cabins and for the line fit in parallel. This is where where you can also in an upgrade area buy something which is more digital. And for some of our aircraft, we have generated data and stored data for a long time, where we even were not possible to analyze those data. This helps us now and we are working since quite some years on methods like predictive maintenance for certain components. When we see a component is failing very often, then we can already for even old aircraft, we can, with the data we already have, we can start some algorithm and to see what are the reasons that this component might fail earlier. And this is also possible not only for brand new aircraft.
Thank you, Stefan. And I think that while you were talking, something came to my mind, which is it's true that with the present crisis, we're seeing older aircraft being phased out to a certain extent, but it's also true that the need for cargo transport in the future will be quite high. There's a tendency, of course, to use older aircraft to transport cargo. So I think we collectively as an industry need to think on whether this trend may mean something for the digitalization process. Torsten, any view on the discussions that we just had?
No, I think the critical part, as we talked about before, is to gather all the different sets of information, what's possible. The neat thing is on technology, what we found is, as Stefan alluded, is in some cases when you do predictive analysis, you can even with technology close the gaps where you may not have a sensor today, right? To fill the white space or the areas where you might have sensors or may not have sensors, or even in today's world, I think some of the older aircraft, they only capture somewhere around 20 to 30% of the data, even though they have sensors all the way. But if for the rest of the data points that may be generated during flight, you may have to predict some of the elements. So as we train the predictive models and work with them and gather the data, it's going to be critical that we work all together, because the more data you have, the better the algorithms are going to be, and the more helpful it will be in the process, especially for older aircraft where some of the data may be available or may not be available right in this area. So technology, as I said before, I think a lot of the technology people have a lot of capability skills, but they may not have the capability or understanding of the systems and the interconnectivity of the systems. And so we need to work together to bridge the two worlds of marrying the technology with the business processes and the business knowledge.
Thank you, Torsten. Thanks very much. Let's move now from the machine to the man. And there's been quite an interesting conversation going on in the chat that I have here, where the floor can put their questions, between a colleague that I think from the question is a young graduate and a professor that has been answering him. And the question is about, well, since we are moving fast into this new digitalized world, shouldn't we maybe hire more inexperienced people, but that have different set of skills, that are more ready to take on this challenge? And I'm a pilot by trade, so I was always taught that you need a mix of new blood, fresh blood, and experience, because this is what will deliver eventually safety. But how are we going to face this challenge in the future? In other words, people like me that have been around for some time now, that started flying on airplanes were designed in the 50s. Are we ready as people to take on this digitalization challenge? And I would like to ask this question first to Bart and then to Professor Andreas, please.
Thank you very much. That's indeed an excellent question. I think it almost comes into the field of psychology there, where we need to do some research and start to collaborate outside of our own technical area where we are very good at and very familiar with. To get acceptance on new technologies and to get the human integration right, I believe there's only one way that will work, and that is to make it attractive for the people concerned. So if you want to, let's say, an example that you hear very often, of course, is can we take the pilot out of the airplane? Or can we fly the airplane with only one pilot, for example? That will, I think, only happen when it is really an attractive proposition also to the existing pilots. And that may be very difficult or even sound impossible right now to our minds. But remember that we also successfully took out the flight engineer in the past, what at the time before that also seemed something impossible. And we successfully did it. So I think if we can make the technology attractive enough and supportive enough to the change, you can actually make changes. So that would be my answer, I guess. And the same is this for air traffic control. If you have the air traffic controllers of today, they are really professionals. They are really good at what they do, looking at scopes and manually regulating air traffic. Now, how can you make it attractive to them without making them feel unnecessary anymore? How can you make it attractive to them to change? I think there's a lot of things we can learn from the younger generations. Because their adaptation towards technology is only based on that. If I look at my teenage kids, they will only embrace new technology if there is something in it for them. So we must make sure that we start to think like that.
Thank you, Bart. Professor Strohmayer, what's your point of view? Do we need more young people that are able to think outside of the box to move faster, or not, or we need a combination? What's your take?
So yes, we need a combination. So I was smiling when I was reading the question in the chat, because we need disruption and creative ideas, that doesn't relieve the students from getting the basics. They have to learn and have to know the basics. There's a skill set which has to be there before you go out. Of course, experience is not so easy to get. You can do internships and so on. So some level of student experience you also should bring. But again, what we need and what we have to provide also from the university side, despite all these new ideas, there's the old basics which still have to be learned. We have to see what we can skip, like manually drawing designs, which what we still have learned that's no longer current. We have to learn 3D design. So the curriculum has to change, of course, but the basics are the basics. And then we have to provide from our side these new ideas, which then everyone can choose as he feels like what suits best to his personality. And then, of course, creativity is needed in industry. I've been in industry before, and I always like the idea of having this team of 1-2 youngsters together with a senior engineer. That is a very productive environment. And this is what we have. I mean, there was a large company in Europe that had a cut in the 90s of all senior experts. That is very difficult. So what we have to make sure is that we have a transition of new and old experience. And we also have to understand, so the older engineers, you said, as a pilot, many things we haven't seen before. We always have to accept that learning is a lifelong process. So we have to have continuous learning, and it doesn't stop at leaving university, that you have to go back and learn things if they come onto your table.
Thank you very much for this answer. There's a specific question from Johannes, which is on MROs. And the question is as follows: how are MROs preparing for the new aircraft generation, which are adopting the new predictive maintenance paradigm, and to which there are limited data and information?
Well, what we are fostering as an independent MRO is that concerning the data being emitted by aircraft or engines, we want to foster control, choice, and competition. That means we want our customers as airlines to have the control over their own data. We want them to have a choice to whom they might give, to which platform they might give the data to be analyzed. And then we also want to foster competition in the market, not to create monopolies on data. And this is how also we try to persuade or convince our customers that this is necessary. And we are preparing for the new generations of aircraft with a lot of cooperations with big OEMs because the new aircrafts, they have a very limited number of OEMs outfitting these aircraft. And that's from the customer side. And how are we preparing in our shops and hangars? So we have done huge investments, fortunately before Corona, to prepare our shops and our production facilities to be able to repair and maintain all these new aircraft types.
Thank you, Johannes. While you were talking, you made me think of something quite important and of a bit of a provocative questions for the manufacturers. So maybe Bruno and Stefan. As we talk about using more and more data and basing everything on data, isn't there a risk to create big monopolies where, of course, the manufacturers will have all the data of an aircraft, and for every single small thing, we will need to get back as operator to the manufacturers and pay more and more to get certain things done. And sorry, once again, I said it's a bit of a provocative question. I'm not suggesting that you are doing that, but isn't there a risk that this may happen if we base everything purely on data? And Bruno, maybe first, and then Stefan.
Yes, could you repeat about the risk you see, because I didn't catch
to create monopolies of data that will then overcharge system for owning the data.
Yes, I think that in our business of linked to business jets, we are not in the same position as Airbus or other manufacturers, because our customers are not in a position to take advantage of having data, because they have not a fleet. They have only one aircraft, or I'd say one or two aircraft. So in fact, they will rely on the manufacturer to give them services which are based on the treatment of data. So they are linked to us to some extent, and we are not competitor with our customer. I think it's different for Airbus with airlines. We are not competitors with our customers, so we are the only one in a position to treat and to treat this data. What we have to take care, it's the relationship with our suppliers, because we need to find the win-win solution in processing the data, in order to give also benefit to our supplier, because we will need the sum of their data in order to treat the problems, etc. And so we have to understand what would be the win-win solutions. And I think today we have not found really what it should be. Is it clear for you? Do you think? So
it's a very clear perspective.
The monopoly situation regarding the customer I think, is not a problem for us.
Okay, thank you very much. And I understand that your business model is different. I mean, your customer base is different from some other manufacturers. Stefan, your point of view on this?
There was some technical problems in the question, so I'm not sure I got it.
Okay, I will repeat it for you. So my question was linked to what was discussed before, and said, because we are now basing everything on data, and data becomes, really not only indispensable, but also becomes the big wealth. So isn't there a risk that manufacturers, for example, or anybody else that owns data may become a monopolist with regards to such data, and therefore abuse the market by holding on this data and selling it overpriced, for example?
There's another risk, which is that as it is all about data, it's not about physical knowledge, that someone who has no clue about aviation at all takes as a service provider is doing the job and is disrupting the OEM. You can see it also from this perspective, and I think we are maybe not so far away from the situation of Dassault than you think, because of course we have the big flag carriers with us, but we also have small lessors, we have smaller airlines who completely rely on us to maintain their operation. So there is not one customized specific solution on this one. I think what maybe is a bit forgotten in all of the discussion, and we spoke a lot about what happens after the handover of the aircraft in the operation, is how to use the data for our industrial process to set up the most efficient and high quality and the fastest possible industrial system, where in the end also I've listened to our customers today. The life cycle, the time to market needs to be accelerated, and we need to better make in the co-development use of the data internally to set up an industrial system internally, which is taking benefit of this data continuity. And then also from this process, our customers will participate a lot thanks to shorter lead times, thanks to short or latest possible changes in the customization and so on, by decoupling airframe and cabin, things like this. So we should not forget that there is a huge benefit from the customers, also from the revolution which is going on inside the OEM's place.
Thank you, Stefan. And I think that one of the key words that we heard today is speed. We need to be faster. We need to be faster to roll out new products. We need to be faster to ensure we have the efficiencies that we need to restart the industry after COVID. We need to be faster if the industry will recover in order to be able to have the infrastructure needed to take care of the traffic demand. And we have slightly over 5 minutes, so maybe this will be the last question to you and to all of the panelists. In order, what do you think are the biggest obstacle in this direction? What are the biggest obstacle in speeding up this digitalization process that I think we all agree is necessary? It's moving, but it's not moving fast enough. And let me start from Stefan, as you have the floor, and then we move on to the other colleagues one by one.
For me, it's clear. If you take the digitalization, all the technology part of it, it's an enabler. And it will happen with or without us, so or so. So for me, the difference makes to overcome this change reluctance in the staff, in all the people who are operating today, the aerospace system, in the OEM, in the airlines, in the whole supply chain. Because if we don't take them with us, we can have the best means, and we will not achieve this acceleration target.
Thank you, Stefan. Bruno, over to you.
Yes. I think that the main obstacle that we have, I don't know exactly where it is, but it's the fact that we have not succeeded yet in our industry to reduce the cycles of development of a product, thanks to the digital solution. It's really something which is painful, and I know the strategy of Airbus with the DDMS, which really target to reduce the cycles. But today we have not yet been in a position to reduce the cycles, because at each time there is a learning curve of new processes that we cannot, I would say that we cannot amortize, or how to say, that we need to pass, and then the cycles of development, they are still the same as they were 20 years ago. So this is really the challenge of our industry, is really to take benefit of these solutions to reduce the cycles. And we are all the same we have all this objective in the aeronautical industry, and it's a shared objective. And for me, it's really the challenge of tomorrow.
Thank you. Thank you very much. Bart, your point of view.
I hope you can hear me. I cannot hear the answers from the others, but so maybe I'm going to say something that has already been said. If so, I do apologize. In my mind, the biggest obstacle to get things really moving faster in digitization is certification. What we see is that it takes so long for a new technology to be approved to use that it is already old news by the time that we get it into the aircraft or into our systems. So I really think we should find ways to work with the regulators earlier on or in another way to make sure that we really certify solutions. One example I always like to give is that we now have Wi-Fi on our aircraft. However, to get it in the flight deck is yet another issue because it is more difficult to certify to use it there. And then you have it there, then there is still uncertainty about how you can use it and what will be allowed to use because of certification issues. While on the other end, if I'm a passenger and I'm using the Wi-Fi, I can just use Flight Radar 24, for example, and I already have a wealth of information that I would really like to have if I was flying the aircraft because it helps me in decision making. So I think certification and onboarding in the process is our biggest hurdle in the near future. Thank you.
Thank you, Bart. Very well made point. And I keep seeing professionals in aviation that tend to informally use off-the-shelf technology to gather some data rather than certified means. It would be interesting to have maybe us on the panel, but in the lack of their presence, I just want to comment that maybe the use or better use or more use of off-the-shelf products in areas where this is feasible would certainly help on top of speeding up certification. So that's something also that I think the industry should be looking at. Torsten, your opinion on all of this?
Yeah. The key thing, I think, as we talked about, is the collaboration. We will see the amount of data that's generated over the next couple of years, in 4 or 5 years. The only way to really collaborate on to work with the data is have a federated system, collaborate on it, that everybody understands what their value is out of the collaboration and the data, and also utilize technology to ensure that privacy or also just basic things like train AI to not give maybe the detailed data away, because A, it could be just too large, or B, it could be too strategic for a company or a person, but to utilize technology in the right way, because as I predict, we're going to have lots and lots of data in 4 or 5 years from now. That is not only the historic data, but also the design data and the future data that will just not allow us to do the single point of a data lake anymore. But we need to think of federated systems. We need to talk about security. We need.
I think we lost our colleague when he was talking. So as we're running out of time, very quickly, let me move to Professor Strohmayer and Johannes. So if you can be concise, please, as we're running out of time. Thank you.
Yeah, the good thing is, being one of the last to be asked, most things have been said. 2 things come immediately into my mind. The one is, as Bart pointed out, certification. So the big gain in development cycle would be in the certification part, virtual certification, but ensuring safety, as it was said before. And the other thing is this digital thread. So a little bit what was just said before. How do we interconnect all these different models, and behind the models, all the different stakeholders, the OEMs, the suppliers, the MRO, and the operators. So how to standardize all these interfaces, to have a communication framework for all these models. Definitely what's not constraining is the creativity of the young engineers.
Thank you. And Johannes?
Short, what is hindering? The first is lack of cash for investments in the whole business. And the second one is the missing understanding that digital transformation is 80% business transformation.
That's quite interesting, and I agree with you, resources would be an issue as we move forward. We run out of time. Torsten, I'm sorry you were cut off, but I think we understood your message. Thanks to all of you for participating today to this panel. I hope our discussions, and I'm sure our discussions were interesting for the audience. There would be much more to discuss about digitalization, but we don't have more time, unfortunately. Thanks once again. A very good afternoon and very good continuation of the conference to all of you. Bye.
Thank you.
Thank you so much. Thank you so much, Giancarlo, Bruno. Thank you, Chair, and thank you, dear panelists, for this great discussion. So this is such a huge topic, digitalization. It sounds so simple at the first sight. Just take the term predictive maintenance. Sounds simple, but the moment you realize that even a small Airbus 319 consists of more than 3 million pieces, you get an idea what kind of challenge is in the field of digitalization. Thanks again, Giancarlo, Bruno, as chair, and the panelists for this inspiring panel. Ladies and gentlemen, in the meet and greet area, now you can talk to Stefan Römelt from Airbus. Feel free also to visit the exhibition hall or the networking area or the partner lounge. It's worth to look at all these places. Our next discussion here in the lecture hall will start at 4:30. Then the focus will be on a world of climate neutral flying. Enjoy your break and see you then.